So we have a basic understanding of angles as of now. We are able to compare two angles. Now let's move on to understanding about specific angles that we use on a day-to-day basis. We use it directly or indirectly. Now let's look into it. Very first angle is a straight angle. This has to do with us taking up a straight line. Considering any point on the line, any of these three, or anything to be honest. The angle subtended by, say, I'll take only one, so it's easier to discuss. This being our vertex, this being our arm 1 and arm 2. This is our straight angle. It is equal to 180 degree. What is this 180 degree? We'll discuss that in time, but just keep that in mind. So basically, if I take up any straight line, for example, I have a straight line over here, and if I take up any point as the vertex, this 2 being the arm, this forms a 180 degree. So basically, these two are examples of straight angles. Okay, so let me put it across in another way. Say I consider a vertex. I will consider this as one of the arm. If I extend this particular line, this ray actually, to the other end, okay, in this way. So it's basically in the same line, right? It's an extension, but on the other side. This is again a straight angle. So there are many ways of thinking about straight angles. So I'm just showing all of them. So this is a straight angle. Okay, it's as simple as that. Next, right angle. Right angle is defined as half of straight angle found by perpendicular line. What does that mean? So I'll show one activity basically. So we are looking at me drawing a straight line, folding the paper. So this is a A4 size paper. So edges are in line, they are parallel to the opposite side and all of that. So I'm folding in such a way that the edges match, right? They overlap. Okay. So then I folded the paper. I get a crease. Considering the point on the straight line being drawn, which is drawn, that is our vertex. And along that fold, I'm drawing a line. So again, I'm showing that the edges overlap. So basically, what is that we are doing? We are dividing the sheet of paper exactly into two halves, right? So when we do that with the paper, we get two lines. Initial line is a straight line, true. So the activity is over here actually. Right, so let me redraw that line, those lines. So this is a first straight line. This is a second straight line. The angle between them, there are actually 4 angles, but all the angles will measure 90 degree. That is, they are right angles. Okay guys, so basically this is the initial entire angle of the straight line, is it not? So this is a straight line. So if this being the vertex, this entire thing is 180 degree. So if I divide this angle into 2 equal half, that's what I did over here. So I divided the entire angle into 2 equal half, and each of them will be 90 degree or right angle. Okay, so pictorially, if I draw any angle, say this is the first arm, this is the second arm. And if I happen to represent in this manner, this is a symbolic representation of right angle. Okay, it's as simple as that. That's our vertex. This is our arm 1 and that's our arm 2. So we can tell that arm 1 and arm 2 are perpendicular lines, or perpendicular, they are perpendicular to each other. This is an example of perpendicular line actually. Right, if I do this arrow thingy on the edges. So this is an example of, so here line L and line M. Line L is perpendicular to line M. This is a symbol of perpendicular. Okay, guys. Right, again, let me take it a bit slow. Let me recap. Straight angles are quite simple. You take a straight line, take any point as the vertex, you will form a 180 degree or a straight angle. If I fold the line or cut the angle into 2 equal half, what we get is a right angle. So 180 divided by 2 is 90, right? Agree? Now, if I happen to get two lines crossing each other such that they subtend an angle of 90 degree, that is, they make an angle of 90 degree, those two lines are said to be perpendicular to each other. This is a word that we need to understand that will help us in the future. So representation, I've shown it here itself, like line AB is perpendicular to, say, EF. This means angle between the lines is 90 degree. Okay, oh, we have the perpendicular line exclusively over here, but anyways, I explained it. Okay, so perpendicular is to do with lines having or making. We have to use the word subtending, but since you guys are just getting introduced, I don't want to impose that on you. Lines making 90 degree between each other. Okay. Now, finally, let's end the concept by looking into investigating whether it's possible to reach the destination using only perpendicular line movement. So we are looking at the activity now. So I think I have explained the game once, but let me explain it again. So we have a turtle. The turtle has to go to the red color square over here. It has to avoid all the black structures. So those are the obstacles. Now the question is, can the turtle go to the square just by using perpendicular angles? So let me try that. So first thing is, it has to turn left. So left and 90. Can you see that? So it was complete to the right. Now it's taken the middle path. So then I'll go forward. I think I have to go 100. Okay, that's good. Then again I'll turn left and again 90 degree. So imagine that you have a straight line over there. I need to cut it into half for it to go exactly in the middle. Then we can go how much? Forward. So if that was 100, how much should we go, guys? Should it be less than 100, more than 100? It's more than 100, right? So each box is like 50. If this entire box was 100, each box length is 50. The amount of movement was 100 in the previous case. So each box is 50. So we have around 3 of them, but I don't want to go to the end of the third one, maybe in the middle. So 50 plus 50 plus 25. So 125. Finally, we just have to turn right, and we can take 90-degree and forward. So this is, I can go 100 aram se, and congratulations, you reached the goal. So were we able to do it? Were we able to use only 90-degree and reach our destination? Answer is yes. Okay. So let's look into that. So we have a right angle over here. We had two right angle. So if I have, say, AB, and this is C, and say this is destination D. So here angle ABC is said to be 90-degree. Okay, they are right angle, that is. What is this 90-degree value? Where does it come from? We'll discuss that in time. So basically, it's right angled. This also is right angled. BCD. Is that correct? Or is it BDC? It's the arm, vertex, and then the arm again. Remember, that's how you measure angles. That's what we discuss, angles. And we'll discuss about perpendicular also. So AB is said to be perpendicular to BC, and BC is perpendicular to CD. Okay, so this is a line segment. Yeah. Right, got it? You also, please, you guys also try using the game and trying to reach your destination by using 90-degree. Let me make it complicated. So when you guys play it, it won't be Sida Sada. I'll make it complicated so that you guys can have more fun. So for me, to save time, I have kept it easy for myself. Level 1 basically. All of this is something that you guys have to copy.